Welcome to the first practice video for our upcoming assessment. We're going to use the binomial theorem to expand each power of a binomial because that's something that we haven't worked a lot on in class. We're going to start with the practice worksheet. You should have this in your resources. This is from the 3-2 lesson on multiplying polynomials. Let's start with a couple of problems that you may or may not have gotten to in class, just to double check to make sure that you are okay with basic multiplying of polynomials. The previous video showed a vertical and a horizontal method of doing this. Multiple distribution is really all you're doing here. You can just take the first term and multiply by each piece in the polynomial, and then take the second term and multiply by each piece, expanding it, and then combining like terms. So let's show that. If I take x and multiply it by each piece, I get x times x squared, which is x cubed, x times xy, which is x squared y, x times y squared, which is x y squared. Then when I multiply the 2y times each piece, 2y times x squared is 2x squared y. Remember to always write your terms in alphabetical order, x before y. 2y times xy is 2xy squared. Notice when I'm writing this, I'm lining up my like terms to make it easier for me to combine. And 2y times y squared is 2y cubed. The only thing left to do is to combine my like terms. I have like terms here and here. So my final answer then is x cubed plus, here I have x squared y plus 2x squared y, so I have 3x squared y terms. And here I have xy squared plus 2xy squared, so I have 3xy squared, and I have plus 2y cubed on the end. So this is my final answer. X cubed plus 3x squared y plus 3xy squared plus 2y cubed. Notice that it is written in standard form, and that's something that you're going to want to focus on every time you multiply or expand or divide. Anytime you're working with polynomials, always write your answer in standard form. Biggest exponent first, and then it goes down. Notice that my y exponents go from the bottom up. All right, well, let's look at number 9, and then we'll start working on the binomial theorem. Looking at number 9, here again, you have a polynomial multiplied times a binomial. So I'm going to multiply each one of these terms times each one of these terms, called multiple distribution. So I'm going to take my 2x and multiply it by each piece, or by each term, and then take my 3 and multiply it times each term. So expanding this one, 2x times 3x squared is 6x cubed. 2x times negative x is negative 2x squared. 2x times 2x cubed is 4x to the 4th. Watch your signs. 2x times negative 2 is negative 4x. And then I'm multiplying my 3 times each of these terms. 3 times 3x squared is 9x squared. 3 times negative x is negative 3x. 3 times 2x cubed is 6x cubed. And 3 times negative 2 is negative 6. The only thing left to do then is to combine my like terms, remembering that when I write my final answer, I'm going to need to write it in standard form. So I'm going to give myself some additional room by continuing over here. Look for the biggest exponent to know which term to start with. So I'm going to start with 4x to the 4th. There's only one x4 term. Okay, so I've used that one. Then I'm going to write my x3 terms. Here I have 6x cubed plus 6x cubed. So I have plus 12x cubed. So those are done. Then I'm going to look at my x squared terms. I have negative 2x squared here and 9x squared here. Negative 2 plus 9 is 7 x squareds, so those are done. Then I'm looking at my x terms. I have negative 4x minus 3x is negative 7x. And all I have left now is my constant, which is negative 6. This is my final answer. Notice that the terms are written in order, starting with the biggest exponent and going down. This is standard form. When you're working these out, be very careful. Go slow, one step at a time. Going too fast is where you're going to make most of your mistakes. So now we're going to work with using the binomial theorem to expand each power of a binomial. We ran out of time in class and didn't spend a lot of time on this, so I want to spend time on it now. In order to do this, we're going to use the Pascal's triangle, which many of you found pretty easy to understand. So Pascal's triangle starts with a 1 at the top and then branches down, 1 and 1. Then, anytime you have two numbers above, you're going to be adding those together. So here you have a 2, and you have a 1 here and a 1 here. Now, it always is going to start and end with a 1. So you have a 1 here now. Add these two together. 1 and 2 is 3. 2 and 1 is 3. And you have a 1 on the end. Again, starting with the 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And you have a 1 on the end. And you can scratch out Pascal's triangle on any note sheet or on the side of any worksheet when you're expanding the power of a binomial. Here we have a 1 on the end. Adding 1 and 4, 4 and 6, 6 and 4, 4 and 1, and bringing that end 1 down. Let's do one more row. Bring the 1 down, adding, 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 and bringing that final 1 down. You should notice a pattern here. First of all, this indicates a plus b to the 0 power. Here we have a plus b to the first power, a plus b squared, a plus b cubed, a plus b to the 4th, a plus b to the 5th, a plus b to the 6th. If it helps you, you can look at when you first started adding, your numbers here go 2, 3, 4, 5, 6, and so on and so forth. And guess what? A plus b to the 7th, after you write your leading 1, the next number is going to be a 7. And then you would add the rest of your numbers in. And you can go ahead and do that. Okay? So, if you have a plus b squared, when you expand this, you're going to have 1, 2, 3 terms in your result. If you have a plus b to the 5th, for example, you're going to have 1, 2, 3, 4, 5, 6 terms in your result. A plus b to the 7th, you'll have 1, 2, 3, 4, 5, 6, 7, 8 terms in your result. And we're going to use Pascal's triangle to expand each power of our binomial. So let's look at number 12. Number 12, you have 2m plus 5 to the 3rd power. So we're going to come down here and look at our a plus b to the 3rd power, and we're going to use that row as a guide. So if we have 2m, make sure you can see what I'm doing, plus 5 to the 3rd power. I'm going to note my a and b values. Okay. My a value is 2m, and my b value is 5, and it is a positive 5. So I'm going to use the a plus b to the 3rd power, because I'm raising this to the 3rd power, to write my initial exponents down. I have 1, 3, 3, and 1. So I'm going to write that down here. 1, 3, 3, and 1. The next thing that I'm going to do is take my a values. And I am starting, since this is cubed, I am starting with a cubed. So I'm taking my a value, which is 2m, I'm going to cube it. Next one I'm going to write 2m squared. The next one is 2m to the first power, so I can just write 2m. This would be 2m to the 0 power, which is just 1, so I don't need to write anything. Then I'm going to work backwards. I'm going to write my b values. Again, cubed, squared, to the first power, and nothing. So my b value here is 5, starting with the cube. Then here I have 5 squared. Here I have 5, and here I have nothing. The rest of it is just about multiplying. Here I'm multiplying 1 times 2m quantity cubed. 2 cubed, 2 times 2 times 2 is 8. And we have m cubed. So there's the first term of my result. Here I have 5 times 3 times 2m times 2m because it's squared. 2 squared is 4. 4 times 5 is 20. 20 times 3 is 60. So I have positive 60, and I have m squared. For the next term, I have 5 squared, which is 25, times 3 times 2m. And you can multiply them in any order. 25 times 2 is 50, times 3 is 150, then bring down your m. Notice in standard form I'm going from m cubed to m squared to m, and then you're just going to have a constant over here. You will not have a variable. 1 times 5 cubed. 5 cubed, 5 times 5 times 5. Well, 5 times 5 is 25, times 5 is 125. So there is your expanded form of 2m plus 5 quantity cubed. We're going to do 3 more examples of these. The next one we'll do together. Then I'm going to ask you to try to break it down, pause the video, break it down, and try to do one on your own. And then I'll show you, and then we'll do one more like that. So let's try one to the 4th power. And give myself a little bit of room here. Okay. Let's try 2 of them to the 4th power. Let's try number 14, 2x minus 2 to the 4th power. So I'm going to start with the problem, 2x minus 2 to the 4th power. I'm going to note my a value and my b value. My a value is 2x, and my b value is negative 2. Don't lose your negative. Then, since I'm expanding a polynomial to the 4th power, I'm going to look at my row, a plus b to the 4th power. 1, 4, 6, 4, and 1 are my beginning coefficients. 1, 4, 6, 4, and 1. Once I have the beginning coefficients from Pascal's triangle, I'm going to start with my a values. I'm starting with my a value raised to the 4th power. And I'm going to work down from there. So here I'm going to have 2x cubed. Here I have 2x squared. Here I have 2x to the 1st power, or just 2x. And to the 0 power, I don't need to write anything. Then for the next row, I'm going to work it in backwards order. My b value, starting on the far right, to the 4th power. Then my b value cubed, my b value squared, my b value to the 1st power, and to the 0 power, I don't need to write anything. If it helps you put a placeholder in here, the exponents here go to the 4th, to the 3rd, to the squared, to the 1st power, and to the 0 power. Anything to the 0 power is 1, so if that helps you put a placeholder in there, that's fine. Here we have to the 4th power, to the 3rd power, squared, to the 1st power, and to the 0 power. Anything to the 0 power is 1, so that gives you a placeholder there. Then all we need to do is multiply and combine. Okay. Multiplying here, we have 1 times 2x quantity to the 4th power. So 2 to the 4th power, 2 times 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. we could go ahead and go through and work our powers of 2. 2 cubed we know is 8. 2 squared we know is 4. That might help us work a little bit quicker. So here we have 16 times 1 times 1 is 16. And our variable is raised to the 4th power as well. Okay? Here we have 8 times 4, which is 32, times negative 2 is negative 64. And our variable x we have raised to the 3rd power. Again, in standard form, it's going to go down. X to the 4th, then x cubed, then it'll be x squared, x, and then your constant. So here, we have negative 2 squared down here, so that's a positive 4. We have a positive 4 here. So 6 times 6. So 6 times 4 is 24. And 24 times 4 is 96. And then, of course, your exponent is 2, so x squared. So here, I have negative 2 cubed, which is negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So I have 4 times 2, which is 8, times negative 8 is negative 64, and my variable is just x. And the last thing I have here is just negative 2 to the 4th power. But you can refer to your first term and see that 2 to the 4th power is 16. And if you multiply negative times itself an even number of times, it's going to come out as positive. So here is your final answer when you expand the polynomial 2x minus 2 to the 4th power. Feel free to pause it and rewatch to make that a little more clear. There is a problem on the quiz, expanding a power of a binomial. So let's go ahead and look at number 17. Let's go ahead and look at number 17. Here's number 17. Okay. This is 3 plus t to the 5th power. So we can go ahead and write down our a value and our b value. A value is 3. B value is t. Okay? Since this is to the 5th power, I'll find my a plus b to the 5th line in Pascal's triangle and go ahead and write down my leading coefficients. 1, 5, 10, 10, 5, and 1. 1, 5, 10, 10, 5, and 1. Next step. Start with my a values, and under the first term, I'll have my a value to the 5th power. My a value is 3 to the 5th power, and go down from there. At any point that you would like to try this on your own to make sure that you can do it, go ahead and do that. Pause the video, and when you start back, you can see how you're doing. Just taking my a values and working them down. 3 is 3 to the 1st power. 3 to the 0 power is 1. So underneath that, I'm taking my b values. And I'm starting with the power that the binomial is raised to. And then working backwards. All the way to t to the 0 power, which is 1. Then I am just multiplying and combining. Starting here, I have no variables, I just have constants. I have 3 to the 5th power. 3 times 3 times 3 times 3 times 3. And any time you want to just scratch this out on your paper and do the math, you're welcome to. You do have the calculator at your disposal. I, of course, would prefer that you not use it as a crutch, because you can do this on paper. 3 to the 4th power is 81 times 3 gives you 243. So here I'm starting with 243. Going to the next term. We saw in the previous term that 3 to the 4th power was 81. Here we need to take that times 5. This was 81 times 5. You can multiply that on paper or in your calculator. And don't forget your variable of t. Next term. Here we have 3 to the 3rd power. 3 times 3 is 9. Times 3 is 27. times 10 is 270, and bring down your variable t squared. Next one, we have 3 squared, which is 9, times 10 is 90. Bring down your variable, t raised to the 3rd power. The next one, we just have 5 times 3, or 15, t to the 4th power, and then our final term, we have t to the 5th power. In standard form, you should write this exactly backwards, starting with t to the 5th, plus 15t to the 4th, plus 90t cubed, plus 270t squared, plus 405t, plus 243. One more to work together here. Number 20. 2n plus 1 to the 6th power. Go ahead and pause the video and try this one on your own. My a value is 2n. My b value is 1. Looking at Pascal's triangle, I can see my coefficients at a plus b to the 6th power, because I am working this to the 6th power. I have 1, 6, 15, 20, 15, 6, and 1. 1, 6, 15, 20, 15, 6, and 1. Then I am starting with my a value, which is 2n, raised to the 6th power. And continuing downwards. Then I'm taking my b value and writing it directly underneath. Now what do you notice about this b value? 1 raised to the 6th power is just 1 raised to the 5 power, 4 power, 3 power, 2 power, 1 power, and 0 power. Did you really need to write those? Probably not. So the rest is just expanding it, or multiplying it. Here we have 2n to the 6th power. Well, n to the 6th power is just n to the 6th power. 2 to the 6th power. Here we have 2 times 2 times 2 times 2 times 2 times 2. I challenge you to work these out on paper and not be so quick to punch the buttons. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So now that we've done this, we can see if this is 2 to the 6th, this is 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared. So here I have 2 to the 5th power, which was 32, times 6. So 32 times 6, 192. So I have a positive 192 into the 5th. Here I have 2 to the 4th, which was 16, times 15. 16 times 15. So that's 15 16 times. Well, 15 times 15 is one of those squares that you should know, which is 225. Then you have one more 15 to add in there. So you end up with 240. So here I have 240 into the 4th. 2 cubed was 8, times 20 is 160 and cubed. 2 squared is 4. 4 15s is 60 and squared. 6 times 2n is 12n, and you end with a 1. It's kind of a long answer. And every exponent you raise higher is going to be a little bit longer answer. So feel free to pause if you need to and rewatch. Now, one quiz question or bonus question to make sure that you watched this. Comment on Canvas after this video or on YouTube. Comment on Canvas or YouTube, wherever you're watching this, with your last name and the last problem number on this video. 5 extra credit points on the quiz. For 5 extra points on the quiz. And don't tell everybody else.